So, welcome to a National 4, National 5 chemistry lesson on atomic structure. This lesson is all about ions. So, the aim is to understand charged atoms, ions, and also be able to explain what an ion is in terms of its subatomic particles. In terms of success criteria, we would want you to be able to state what an ion is, explain how a positive ion forms, explain how a negative ion forms, and to be able to calculate the numbers of protons, neutrons, and electrons for a given ion. Now, charged atoms, that's what ions are. Now, the atoms of any element have an equal number of protons, those are things with positive charge, and electrons, those are things with negative charge and are therefore neutral. So atoms have the same number of protons and electrons, and because protons have positive charges and electrons have negative charges, they cancel each other out and you end up with something neutral. So for example, helium, 2 protons, 2 electrons, copper, 29 protons, 29 electrons, and so on down that table. So what is a charged atom? If an ion is a charged atom, what does that mean? How does that happen? Well, ions are atoms that have either had extra electrons added or have lost electrons. So ions, the only way an ion can form is if something happens to the electrons. Nothing ever happens to the number of protons or neutrons when we're talking about ions. It's only electrons that change. If an atom gains an extra electron, it will become a negative ion. And some atoms will gain more than one electron, and for every electron they gain an extra negative charge. So if you gain 1 electron, you become 1 minus. If you gain 2 electrons, you become 2 minus. If you gain 3 electrons, 3 minus, etc. If you lose an electron, you become positive. So if you lose an electron, you become positive. If you lose 1 electron, you become positive 1. If you lose 2 electrons, you become 2 positive, and if you lose 3 electrons, you become 3 positive. A general rule is that metals always lose electrons to form positive ions, and non-metals always gain electrons to become negative ions. So metals form positive ions, non-metals form negative ions. And the reason why this charge happens is because you no longer have an equal number of protons and electrons. So electron arrangement in ions. When an atom becomes an ion, its electron arrangement will change. So the electron arrangement of ions will always be different compared to the original atom. So we've got 2 different elements, and we're going to compare the electron arrangement of the atom compared to the ion. So the first one, Na, that's sodium. Sodium is a metal. And if you look on page 6 of your data booklet, you will see that sodium has the electron arrangement 281. Now, sodium positive, it's formed a positive ion, and there's no number beside it, and that means that there's 1 of the charge, so it's positive 1. It must have lost an electron. It's lost an electron, so it's going to lose the 1 from its outer shell, and so its electron arrangement is 2,8. P is phosphorus. Phosphorus is a non-metal, so it should form negative ions. Now, if you look at page 6 of the data booklet, you will see that phosphorus has an electron arrangement 285. Phosphorus forms a 3 minus ion. If it's got 3 negative charges, that means 3 electrons have been added onto the structure. And if we've added 3 electrons on, they're going to go into the final shell, and it is 2, 8, 8. If you look at the electron arrangements of the sodium ion and the phosphorus ion, you can see that they both end in 8. And that represents a full outer shell of electrons. And this tends to happen. And if you have the data booklet, page 6, handy, if you look at the electron arrangements of group 0, the noble gases, you will see that when sodium formed a sodium ion, it now has an electron arrangement that matches neon. And phosphorus, when it's formed a phosphorus ion, it has an electron arrangement that matches argon. And this is a general rule. When an atom forms an ion, it will change its electron arrangement so that its new electron arrangement will match up with one of the noble gases. It's usually the closest one to it. So the closest one might be the one on the row before, or the period before, or it could be the one on the same row as you. But if you've written down the electron arrangement for an ion, a way to check that it's correct is to see, does it match with any of the noble gases? If it does, you're probably correct. Now here's lithium forming a lithium ion, and we're going to explain what's going on. Lithium is a metal, so for this process we're going to see how a lithium atom forms a positive ion. Now as an atom, we've got the mass number and the atomic number for lithium shown in the box on the right hand side. Its atomic number is 3, and in an atom the atomic number is the same as the number of protons, and the number of protons is the same as the number of electrons, so it's got 3 electrons. If we look up the electron arrangement, if we look up the group that lithium is in group 1, and that means that it's got 1 electron in its outer shell, and it must have 2 electrons in its first shell. In its second shell, it's got 1 electron. And the electron arrangement is 2, 1, and you can see that on page 6 of the data booklet. And this is a representation of what lithium looks like. The nucleus, and then first shell with 2 electrons, second shell with 1 electron. When lithium forms an ion, it's going to form a positive ion. You always want to end up with a full outer shell. And the option that lithium has, lithium could lose 1 electron to empty that shell, or it could gain 7 electrons to fill that shell with 8 electrons. Atoms are lazy. They always do the thing that's easiest. Losing 1 is easier than gaining 7. So lithium loses 1 electron. Once it loses that electron, its new arrangement will be 2 on its own, and this would be the diagram. So you can see it's only got 1 full shell, and then the next shell is empty. You wouldn't even need to draw that second shell if you were asked in an exam. We'll look at, in this case, we'll look at a non-metal. So oxygen is a non-metal, and it will form negative ions. We have got the mass number and the atomic number in the box on the right hand side. For an atom, we know that the atomic number equals the number of protons, and the number of protons equals the number of electrons. So that means that oxygen has 8 electrons. In its first shell, it's going to have 2 electrons. In its second shell, it has 6 electrons, and it has an electron arrangement 2, 6. Now when it forms an ion, there's a diagram of it, it's got 6 electrons. When it forms an ion, it's a non-metal, so non-metals form negative ions. They do so by gaining electrons. It's going to gain 2 electrons. Now remember, atoms always want to end up with a full outer shell. They can do this by losing or gaining electrons. For oxygen, it could gain 2 or it could lose 6. Atoms are lazy. Oxygen does the easiest thing. The easiest thing is to gain 2 electrons rather than lose 6. So it gains 2 electrons. Those electrons go into the outer shell, and that means that its new electron arrangement is 2, 8. And those 2 electrons are added in. We now see it's got a full outer shell. So what we've seen is that metal ions form positive ions by losing electrons. Non-metals form negative ions by gaining electrons. Always, once an ion has formed, the final ion will have a full outer shell and its electron arrangement will match up with one of the noble gases in group 0. So when it comes to working out the number of protons and neutrons and electrons in atoms and ions, well, the rules from atoms were the number of protons equals the atomic number, the number of neutrons equals the mass number minus the atomic number, and the number of electrons equals the number of protons. That is not true anymore for ions. Now, protons and neutrons are exactly the same in an ion. Protons still equal the atomic number. Neutrons still equal mass number minus the atomic number, but electrons in an ion equal protons minus charge. So you can see that that is where they differ. Protons and neutrons are exactly the same, but it's just the number of electrons that changes. So what we're going to look at now is a couple of examples. So we're going to compare the chlorine atom to chlorine as an ion. And we're going to use those rules that we looked at on the previous slide. So protons in an atom equals atomic number, which is 17. Neutrons is mass number minus atomic number, which is 35 minus 17, which gives us 18. And chlorine, because there's no charge written in the top right-hand corner, we know it's an atom. And if it's an atom, electrons equals protons, so that is 17. And our electron arrangement is 2, 8, 7. When chlorine forms an ion, it is a non-metal, so it forms a negative ion, and it's got a minus charge. There's no number written there, that means that it's -1. So protons again, the rule is protons is atomic number, which is 17. Neutrons, mass number minus atomic number, which is 35 minus 17, which is 18. And electrons this time is protons minus charge. So that is 17 minus, and then we're subtracting -1. Now, if you have 2 minuses beside one another, they become a positive. So 17 minus -1 is the same as 17 plus 1, which gives us 18. And the new electron arrangement is 2, 8, 8. Now, if we compare the number of protons to the number of electrons in the chlorine ion, we can see that there are more electrons than there are protons. If an atom has more electrons than it has protons, it will be negatively charged. We're now going to look at calcium. So calcium, as an atom, its proton number, number of protons, is equal to the atomic number, which is 20. Neutrons, the mass number minus the atomic number, which is 14 minus 20, which gives us 20. And because there's no charge written in the top right-hand side, we know that the number of electrons equals the number of protons, which is 20. And we have an electron arrangement of 2, 8, 8, 2. Now, calcium is a metal. It forms a positive ion. Calcium forms a 2 positive ion. Protons again, is the atomic number, it's 20. Neutrons, again, mass number minus atomic number, which is 40 minus 20, which gives us 20. And finally, electrons is protons minus charge. Now this time it is 20 minus positive 2. If we have a negative and a positive, it is a negative, so it's 20 minus 2. That gives us 18. And our electron arrangement is 288. You'll notice for calcium that as an ion, there are more protons than electrons. If an atom has more protons than electrons, it is positively charged. So now we've got our set of past paper questions from a National 5 exam. You can take your time to try these, pause the video to give yourself more time. But the first one is identify two elements with similar chemical properties. What they're looking for in that question, if you've got similar chemical properties, that means two chemicals that are in the same group. And the answer to that one is magnesium and calcium, B and E. The element which can form ions with the same arrangement as argon, for that one, what you're doing is you're going to look for elements that are either just before or just after argon on the periodic table. So phosphorus, sulfur, chlorine, gallium, calcium, potassium, those are the elements around argon. There's 3 before, 3 after. Calcium is in that range, so it is going to form an electron arrangement the same as argon. So it's B for that one. When an atom X of an element in group 1 reacts to become X positive, what happens? Does the mass number decrease? Does the atomic number increase? Does the charge of the nucleus increase? Or does the number of occupied energy levels decrease? Well, the answer is D. The mass number and the atomic number, we have seen, they are the same in an atom and an ion, so nothing's going to happen there. The charge on the nucleus, well, when an atom forms an ion, it's all to do with electrons, and electrons are nothing to do with the nucleus, so nothing's going to happen to the charge of the nucleus, and that leaves us with D, the number of occupied energy levels decreases. And that's because in group 1, there's 1 electron in the outer shell. If a group 1 atom becomes an ion, it's going to lose that electron, and that energy level is going to empty. So we're going to have 1 less energy level occupied. Which one of these represents a positively charged ion? Which one of those represents a positively charged ion? Well, this one, the answer is D. You can tell if an ion is positively charged because it will have more protons than electrons. You can see in A, B, and C, they do not have more protons than electrons. If you were looking for which atom is negatively charged, you'd be looking for the one that has more electrons than protons, and that would be A. And B and C have the same number of protons as electrons, so that would make them neutral atoms. We have got a final question here, I think. Which of the following particles contains a different number of electrons from the others? So this one, you need to look at the electron arrangements of the atom and then see what will happen to them when they form ions. Now for this one, the answer is sodium. Because sodium will have an electron arrangement that matches neon, whereas chlorine and sulfur, when they form ions, they have an electron arrangement that matches argon. So hopefully now you're able to tell me what an ion is. An ion is a charged atom. You'll be able to explain how a positive ion forms by losing electrons, explain how a negative ion forms by gaining electrons, and you should be able to calculate the number of protons, neutrons, and electrons for both atoms and ions. I will catch you next time. Thank you for watching this video.